Today, we step inside a massive open industrial recycling facility where hundreds of old, rusted M142 HIMARS systems await transformation. As we uncover the precise, large-scale process that turns complex military machinery into reusable industrial raw materials.
Across a vast expanse of sunlit industrial terrain, where the horizon shimmers in the heat of midday light, rows upon rows of old, rusted M142 HIMARS stand motionless. Once symbols of advanced military mobility and precision engineering, these aging systems now await a different destiny. This is not a story of deployment or defense. This is the story of transformation, the controlled, methodical, and highly technical rebirth of complex military machinery inside one of the largest open recycling facilities in the world.
Check serial number.
Confirmed. Adding notes to the manifest.
Moving to Section 5, Chassis Integrity. The chassis needs extensive rust removal before we can dismantle it. Yes, tag it for heavy oxidation. Check the exposed wiring for damage too. The extent of the damage varies.
Yeah. Look at the rust on these axles.
Let's check the hydraulics. The rust is heavy here. Note that down. Over there needs more inspection. Keep it steady there. Almost done draining this one.
The process begins as fluid extraction teams begin their work. Large sealed recovery units connect to fuel lines and hydraulic reservoirs. Under daylight, the transparency of extraction hoses reveals the careful draining of residual fluids into containment tanks. Environmental technicians monitor gauges and digital displays to ensure zero leakage. Spill containment berms surround the working zone. The ground remains immaculate.
Almost done. Move the bucket over here. Roger that.
Next comes the removal of sensitive electronics. The old rusted M142 HIMARS contains layered wiring harnesses, control modules, communication units, and composite enclosures. Teams equipped with anti-static tools dismantle panels and carefully disconnect circuit boards. These components are sorted, some destined for specialized electronic recycling streams, others for material recovery. Each vehicle tells a story of layered engineering: high-strength steel chassis rails, aluminum structural members, composite paneling, copper wiring, titanium fasteners, rubber seals, advanced alloys developed for durability and weight reduction. Now, each of those materials must be separated with surgical efficiency. Under the full clarity of daylight, heavy hydraulic shears approach the first stripped chassis. The sound is deliberate, controlled, a powerful mechanical compression rather than chaotic destruction. Sections of frame are cut into manageable lengths. Sparks scatter briefly but fade quickly in the open air. Overhead, gantry cranes move with steady authority. Massive electromagnets descend and lift severed steel beams from the old, rusted M142 HIMARS chassis. The camera captures the contrast: rusted, weathered surfaces against the clean industrial geometry of modern recycling equipment.
Grab the torque wrench.
Initiating retrieval sequence. Copy that, starting to pull now. Check alignment, watch.
The rust is heavier here than the estimates. Take a look at the chassis. It's completely stripped. I'll mark this one for the lower priority stack. The chassis integrity is compromised on this unit. Log that as number 712.
I'm marking the cab for salvage.
Roger that.
The engine appears to be salvageable. Check the transmission fluid. The corrosion is severe. Check the serial numbers on those chassis. Okay, got it. Move to the next vehicle.
Further into the yard, plasma cutting stations operate inside designated safety perimeters. Operators guide computer-assisted torches along predefined structural points. The precision ensures that alloy categories remain uncontaminated. High-carbon steels are separated from structural mild steels. Aluminum launcher housing sections are cut cleanly and transferred to non-ferrous processing zones. The sun remains constant overhead, illuminating airborne metallic dust that glitters momentarily before settling into controlled collection systems.
Keep it steady. Guide it slightly to the right. Copy that. Moving slowly right. Watch the exhaust pipe. Lower it now. All right, cables are hooked up. Take the strain. Hoist clear. Checking the lift angle. Clear on my side. Take it slow. Engine's coming up. Watch your step down there. Keep it steady. Down a little to the left. Okay, got it. Looks good from here. Bring it down.
Extensive corrosion here. We need to document the electrical damage.
Agree.
Mark the exposed wires. Checking the armor thickness now.
The paint is heavily corroded here.
Yeah, look at this rust streak. It's deep.
And the wiring inside is a complete mess. Lower it slowly. Watch the pile. Copy. Lowering now. Clear the zone. Stand back.
Beyond the cutting operations lies the mechanical reduction zone. Here, industrial shredders, towering machines with reinforced steel teeth, receive segmented components of old rusted M142 HIMARS structures. The sound is deep and resonant as heavy steel sections are drawn inward and fractured into uniform scrap sizes. Conveyor systems transport the shredded material toward magnetic separators. Magnetic drums spin slowly, pulling ferrous fragments away from mixed material streams. Non-ferrous metals fall onto separate conveyors. Eddy current separators isolate aluminum. Vibratory screens remove contaminants.
Lift it up, slowly. Careful with the hydraulics. Copy that. We're clear on this side. Watch the sparks. Moving it now. Keep it steady. Watch the cables. All right, ready to lower.
Each stage is part of a choreography designed to maximize recovery rates and material purity. Hundreds of old, rusted M142 HIMARS units move through this cycle over months.
Okay, lowering it down now. Clear. Bring it to the left a little. Watch your feet. Aligning. Hold it. Okay, settled. Ports out. Keep it slow and steady. Watch your alignment. Almost there. Bring it in.
In another section of the facility, aluminum from launcher assemblies is melted inside controlled induction furnaces. Under bright daylight streaming through overhead skylights, molten metal glows white-hot within refractory-lined crucibles. Operators monitor temperature readouts. Samples are extracted for spectrographic analysis to verify alloy composition. Recycling complex military systems is not simply a matter of materials. It is a reflection of industrial responsibility. The life cycle of heavy equipment does not end at retirement. It transitions. Materials that once supported strategic mobility will become construction beams, automotive frames, rail components, or renewable energy infrastructure. Workers move steadily through the yard. Crane operators, environmental engineers, metallurgists, logistics coordinators. Each individual plays a precise role in the transformation of old, rusted M142 HIMARS units from obsolete hardware into raw industrial feedstock.
Keep it steady. Watch the temperature. Clear. Bring it back up. Keep it
it steady. Watch the flow rate. Looks good. Check the temp. Monitoring the heat. Keep it flowing steady. Watch the overflow. Almost there. Tilting up. Keep checking the rows carefully.
As the sun lowers toward the horizon, casting warm golden tones across the facility, the last processed steel bale is loaded onto a transport trailer. The camera lingers on its dense metallic surface, anonymous, unrecognizable, yet filled with history. Industrial progress is not only measured by what is built, it is measured by how responsibly we dismantle. The recycling of old, rusted M142 HIMARS inside this mega-open facility demonstrates the capacity of modern industry to manage complexity, reclaim value, and reduce environmental impact, even from the most advanced and specialized machinery.
Inspection is complete. Let's stack them. Okay, ready to transport. Watch your step with the forklift. Keep it slow, watch your corner. Bring it down here. Looks good, marking it. Keep it steady, watch the clearance. Looking good, batch ID check. Forks down. Next bay. Okay, move it slowly to the right.
Copy that, moving slow.
Stop, check the stacking integrity here. Verified, looks good. Keep it steady, watch the clearance on the right.
Copy that, coming in slow.
Looks secure, mark that one for dispatch.
Keep it steady.
Down a little.
Okay, lowering.
Check the straps, make sure they're secure. Okay, I'll log it. Minor imperfections on them, sir.
The markings on these seem correct.
Yes, they meet the spec.
Forklift's ready. Let's move this batch.